So let's dive into some trigonometric functions right here. Angles and angle measures. Now, starting off, radian measure, a unit different from degrees used to measure angles. So just sort of giving you guys a bit of backstory what's going on right here. When you look at a circle, and looking at a circle, we'll talk about this in a bit more depth as we go on through this. But you guys know that in a circle, if I were to start at one point and run my entire way around it, then that would be 360 degrees. So we say that one full rotation of a circle is 360 degrees, or one full rotation of anything is 360 degrees. Now, the problem is that 360 degrees is actually kind of an arbitrary number. Its history is rooted back in ancient Babylonia, like thousands of years ago. So mathematically speaking, the 360 degrees doesn't actually give us the exact values and the precise values that we like to get. So instead what we use is we use something called a radian measure. Now, 1 radian is the measure of the central angle subtended by an arc equal to the length to the radius of the circle. Wow, what does that really mean? And what it means is we come down to right here. Now, you see, the circle has 360 degrees, and the circumference of the circle is 2 pi r. If the radius measure is 1 unit, then the circumference equals 2 pi. So from before, when we said that we had that circle, and I divided it into 360 degrees, well, if I had a circle, and I said that the radius was equal to 1, then the distance around it would be equal to 2 pi. Why? Because c equals 2 pi r. So the distance around my circle is 2 pi, or rather, we say that one rotation is equal to 2 pi. So I can say one rotation is equal to 360 degrees, or I can say one rotation is equal to 2 pi. And that 2 pi is what we call radians. As such, we say 360 degrees equals 2 pi radians, or dividing both sides by 2, we say 180 degrees equals pi radians. Now, we're going to talk a bit more about arc length in a bit later on in this lesson, so I'm not going to get too caught up in that piece of it right now. What we're instead going to do is we're going to focus on just converting from degrees to radians or radians to degrees. So I have 180 degrees equals pi radians. That means, well, that 1 degree would equal pi over 180 radians. If 1 radian equals, if pi radians equals 180 degrees, that means that 1 radian, or I divide both sides by pi, would equal 180 all over pi degrees. And what that does is that actually gives us our conversion ratio. So if we're trying to convert from degrees to radians, what I would do is I'd multiply by 180 over pi. If I'm trying to convert from radians to degrees, I multiply by 180 over pi. Convert the following from degree to radians, express your answer in terms of pi. So I want to take this in degrees and I want to convert it into radians. So 30 degrees, and then I just multiply this by pi over 180. Now, one thing, whenever I'm doing these conversions, I've always kind of visualized doing the conversions as when I'm turning into radians, I'm putting the pi in because it's on top, and when I'm converting into degrees from radians, I'm taking the pi out because it's on the bottom. So then we get 30 pi all over 180, and this would equal pi by 6, which is actually going to turn out to be a very important value once we get to something called the unit circle. I check out the next one. So what we have right here is we have 315. So I go 315 multiplied by pi over 180. Now, an effective way to do this on your calculator is you can just sort of ignore the pi and then go 315 all over 180 and then convert it into a fraction, and this one gives us 7 pi over 4. Negative 225, yes, we can have negative angles. We will talk about that in a future lesson, but for right now, all that I'm going to do is I'm just going to go negative 225 multiplied by pi over 180, and then once I get my cancellations, that gives me 5 pi all over 4. Convert the following from degrees to radians. Express your answer to the nearest tenth. So in this case, what we're going to be doing is we're just going to be straight up using our calculators. And with radians, we have the advantage it's easy. So convert the following from degrees to radians. So again, I just go 70. I multiply that by pi over 180, so you go 70 multiplied by pi, and then that's divided by 180, and this equals approximately 1.2 radians. 205 multiplied by pi divided by 180, and this one will equal approximately 3.6 radians. And finally, 342 multiplied by pi divided by 180. And this one's going to give me negative 5.969. But rounding this up to the nearest tenth, it'll be negative 6.0 radians. And just up here, I just noticed I forgot to toss the negative sign on there. So that'll give us negative 6 radians. Convert the following from radians to degrees. And again, we want to express this to the nearest tenth. So for this, what's happening? I'm just multiplying by 180 all over pi. So I go 4.25 multiplied by 180 divided by pi. And that would give me 243.5. Negative 1.3 multiplied by 180 divided by pi, and that gives me negative 74.5. Pi by 4, this one we can actually get a bit more of an exact answer for. So I go pi over 4, and I multiply this by 180 over pi. That cancels off my pi's, and then I get 180 divided by 4, which equals 245 degrees. And I'm just going to write the degree symbol on each of these. And then finally, negative 7 pi over 3 multiplied by 180 all over pi. That gives me the cancellations. And I get 7 times 180 divided by 3. And this would give me negative 420 degrees. So when we're converting degrees to radians, we multiply by pi over 180, and radians to degrees, we multiply by 180 over pi. Now the next thing that we're going to do is we'll talk about arc length, but I will get to that in the next little piece.